My dear students, in this video I am going to start a new topic for 12th standard students. The topic is vector algebra. Vector algebra. This topic, vector algebra, is given in both the streams, in CBSE and state board syllabus also. I am going to introduce this vector algebra first for CBSE students. After completing the CBSE syllabus given in vector algebra, and then I am going to state board stream. Because in the state board stream, there are some more topics given which are not given in the CBSE syllabus. Therefore, first I am going to introduce the topic for CBSE students, and then after completing this CBSE syllabus, after completing the syllabus for CBSE students, we will go to the state board stream. First, introduction. Definition of a vector. Definition of a vector. How can you define a vector? This vector is a new terminology which we have heard in this 12th standard that you have not studied so far. But in the vector algebra introduction topic is given in 11th standard for state board students. In the state board syllabus, this vector algebra is introduced in the 11th itself, and addition to that, applications are given in the 12th standard. Whereas in the CBSE syllabus, we have found this topic only in 12th standard. See, definition of a vector. A vector is a quantity which has both magnitude and direction. A vector is a physical quantity. A vector is a physical quantity. It's a quantity which has both magnitude and direction. Magnitude and direction. This is the definition of a vector. So, a vector is a quantity which has both magnitude and direction. It is given by, you consider, this is the point B on the line and this is the point A on the line. AB is a vector. It is defined by the notation AB vector. AB above that and arrow marks. Where A is the initial point of the vector and B is the terminal point of the vector, end point of the vector. This vector is also given by a single letter A vector. If you define a vector in two letters, it should be in capital one. Or in a single letter, small letter, you can define a single letter as a vector, A vector. This AB vector is also defined by a small letter vector, A vector. So where A is the initial point of the vector, A, and B is the terminal point of the vector, J, the direction is from A to B. So this is a quantity which has both magnitude. Magnitude of the vector is distance AB. The direction of the vector is from A to B. So AB is a vector whose initial point is A. A is its initial point. B is its terminal point. B is its terminal point, and modulus of AB, determinant AB, modulus of AB is the magnitude of the vector. Magnitude of the vector AB. You have to read it as AB vector. Magnitude of the vector AB. that is distance AB. Magnitude of vector AB is just AB, distance AB. Its direction is from A to B. Its direction, the vector's direction is from A to B. So this is the notation or definition of a vector. AB is a vector whose initial point is A, terminal point is B, its direction is from A to B, and modulus of AB is the magnitude of the vector AB, and it is given as just AB. Its direction is from A to B, and also AB vector is defined by a single letter A vector, and modulus of AB is nothing but modulus of vector A. It is equal to just A. We can define like that also. This is the definition of a vector. Okay. Next, definition of a scalar. So vector is a quantity which has both magnitude and direction. Now, scalar. The definition of a scalar. A scalar a scalar is a quantity which has only magnitude. It has only magnitude but no dash. The scalar has no dash. A scalar is a quantity which has only magnitude. It has no direction. This is the definition of a scalar. So scalar is nothing but a single quantity, magnitude only. That means the constants are scalar. Numerical constants are scalars. Example. And also constants are called scalars. Now examples of scalar and vector. Scalar is a quantity which has only magnitude. Constants and also the definition is the examples of scalar: time, volume, distance, weight, angle, height. These are the examples of scalar. Vector, example of vector is force of a moving particle, force, velocity, acceleration, and moment or torque. These are the examples of vector, force, velocity, acceleration, moment or torque. These are the examples of vector and these are the examples of scalar. Time, 10 o'clock, volume, 10 centimeter cube or meter cube, distance 5 centimeter, weight 10 kilogram, angle 40 degree. These are the examples. Similarly, force, velocity 10 meter per second, acceleration meter per second square, 5 meter per second square, moment out like that. These are the examples of vectors and these are the examples of scalar. Vector has both magnitude and direction. Scalar has only magnitude. Next. Now let us define position vector. position vector of a point P. Suppose this is a point P defined in a plane or space. Vector is always defined in a space mainly. P is a point. O is the origin. The position vector of the point P with respect to the origin O is called OP vector. Let P is any point in the space or plane, whatever it may be. OP, O is the origin. With respect to the origin O, the position vector of the point P is OP vector. This is called position vector. Position vector is always referred with the origin. The position vector of a point, P with respect to the origin O. The position vector of the point with respect to the origin O is defined by OP vector. It's also called R vector. Position vector. The position vector of a point P with respect to the origin O is OP vector, which is equal to R vector. The position vector is always referred by the initial point as origin only. The position vector as the initial point always origin. With respect to the origin, any point defined is called OP vector, and this direction is from O to P. This is called the position vector. The modulus of the OP vector is equal to R vector, modulus of R vector, like that. Magnitude can be defined by mod of OP vector is equal to modulus of R vector, which is we can call by R, distance R. So the position vector is with respect to the origin, any point P, its position vector is OP. Next, types of vectors. Next, we are going to define different types of vectors. Types of vectors. First one, zero vector. Zero vector is a vector whose magnitude is zero. Zero vector is a vector whose magnitude is zero. It is denoted by zero vector, like that. Zero vector is a vector whose magnitude is zero. It is denoted by zero vector, and it has no direction. Zero vector has no direction. And modulus of the zero vector is zero. And also we can say the initial and terminal points of a zero vector is vector of same. The initial, since there is no direction, the initial and the terminal. Initial and the terminal points of a zero vector. Initial and terminal points of a zero vector are same. AA. This is called zero vector. So this is the point, initial point A, terminal point A. Both are same. And also it has no direction. Or otherwise, if you start from A, if you reach again A, it's also zero. Start from A and ends with A. Not only a simpler form, but whatever it may be. A, this is the point A. B, C, D, E, again A. Like that, if you go on with the different points, this is called the AA vector. AA vector. It is given by zero vector. There is no direction. Initial terminal points are same. Magnitude is zero. These are the features of a zero vector. Next definition, unit vector. Next one, unit vector. It is a vector whose magnitude is 1. That's all. Zero vector magnitude is 0, unit vector magnitude is 1. The unit vector, it is a vector whose magnitude is 1. It's called unit vector. That is, unit vector whose magnitude is 1, it is denoted by, the unit vector is defined by or denoted by cap notation, A cap. Instead of arrow notation, unit vector are defined by cap notation. A cap is a unit vector whose modulus A cap equal to 1. A cap and its modulus is 1. Therefore, A cap is called unit vector A. A cap is unit vector A. It is read as unit vector A. Its modulus is 1. So, zero vector we have seen, unit vector, and third one is co-initial vectors. Third one is co-initial vectors. Co-initial vectors. These are the vectors whose initial points are same. Suppose you can co-initial vectors is OA, OB, OC. Suppose O, P, Q, R. OP, OQ, OR are called co-initial vectors. OP, OQ, OR are called co-initial vectors whose initial points of these three vectors, the initial point is only one and the same. That means O or A, whatever it may be, AP, AQ, AR also we can say. Co-initial vectors are, for example, instead of O you can write it A also. AP, AQ, AR, whatever it may be, because if you don't confuse the position vectors. Suppose the initial point is origin, I didn't say this is origin, it's an initial point O. Co-initial vectors are vectors whose initial point is same. OP, OQ, OR are co-initial vectors whose initial points are, initial point is same, O. Next, equal vectors. Fourth one. Equal vectors. vectors are said to be equal, the magnitude and directions are same. For example, this is AB, sorry, it's AB vector. PQ is another vector. Directions are same and their initial points need not be same. PQ and AB are equal vectors. AB vector is equal to PQ vector, or otherwise you call this is vector A and this is vector B. So A vector is equal to B vector. These two vectors are equal if these two vectors have same magnitude and direction. If the two vectors are equal, then they have same, then their magnitude and direction are same, equal, then the magnitude and the magnitude and direction are same. This is the definition about equal vectors. Irrespective of the initial point. Irrespective of the initial point. Negative vector. Then fifth one is negative vector. If AB is a vector, whose initial point is A and the terminal point is B and its direction is AB, AB is a vector, its negative vector is BA. The negative vector is defined by BA, initial point B, terminal point A. This is its negative vector. BA is the negative vector of A. Its direction is from B to A. So, BA vector is the negative vector of AB. This is minus A always. BA vector is negative vector of AB or minus A. Minus A vector. So, negative vectors mean if a vector is given by a direction AB and BA is in opposite direction. Negative vector has its opposite direction of the given vector AB and it is given by a symbol minus A. So, that's all about the negative vector, and these are the definitions of the vector we have defined. And one more vector notation is, suppose this is north, this is south and east, west. Suppose you have to find a vector OP 40 degree in the southwest. It is the notation of OP vector. So this is called OP vector is 40 degree of south western side. Southwest is called. So vector OP, this is an example of another vector example defined in a plane. OP vector in this diagram, OP vector is a vector which is at 40 degree in the southwest direction. southwest. South-western direction 40 degree is defined by a vector OP. Like that, vector can be defined in different system, coordinate system. This is first quadrant, second, third, fourth, whatever it may be, but it is always north side is in the upper side, north, south, east, west. Okay, right hand side is this, western side, left hand side is west. Like that, a vector can be represented in the plane also. So I will stop here. We will continue the next idea in the next video. Thank you.